we're going to solve the system by any algebraic method that we choose. And this is going to be a three-variable system. So what we're going to refer to by any algebraic method is generally the addition method, Cramer's rule, or matrices. Those are the three that we worked out in class algebraically for solving a three-variable system. And if you want to go through any of these methods on your own, see if you can figure out how to make them work based on how we did them. For an example here, I'm going to use the addition method to solve. Okay, so in this situation, what we're trying to do is look, how are we going to cancel out the x's, the y's, or the z's? And again, we have three equations here, equation 1, equation 2, and equation 3. So I'll go ahead and label them 1, 2, 3 so we can call them by their number as we go along. It's looking like the y's are set up pretty well to be canceled out if we were to add them together. So that's what I'm going to start out here doing. I'm going to start out by taking equation 1 and equation 2 and canceling out the y's on each of those. Okay, so do we need to do anything in particular to cause the y's to cancel? In this case we don't, because they're already negative and positive y. So if I just add these equations together, we'll get a 2x and looks like a plus 5z equals negative 15. We'll call this equation 4 for later reference. So now that we've canceled out y one time, we've got to do it again. So what I'm going to do is now take equation 2 and 3, do the same thing to cancel out y. These are already set up again very well so that the y will cancel out immediately. So equation 2 and 3 set up this way. We'll add term by term. Putting together the x's, looks like we get a 6x, negative positive y cancel, plus 5z equals negative 35. And we'll call this our new equation 5. Okay, so now we're done canceling out the y twice. Now we're down to two equations with two variables. We'll look to see how are we going to continue to cancel out either the x or the z. So if you look at these two equations together, which one looks easier to cancel out, the x or the z? I'm thinking the z is set up fairly well to cancel out. If one of these 5 turns to negative 5, then it will cancel out. So what I'm going to do here is I'm going to take the top equation and multiply by negative 1. And that's going to change the signs around, flip around all those signs. So this will look like negative 2x minus 5z equals positive 15. Just flipping around the signs is really all that accomplishes. But now when we add these equations together, we'll see the z's are going to cancel, and we're going to be left with 4x equals negative 20. And now it's just a matter of dividing out the 4, and we'll get x is equal to minus 5. Now that we've solved for one of the variables, we can work our way back up, plugging in the numbers until we've solved for the rest of the unknowns. So what I'm going to do is substitute x equals negative 5 into either equation 4 or equation 5. I'm going to choose to use equation 4. So if I take negative 5 in equation 4 for x, it would look like 2 times negative 5 plus 5z equals negative 15. That'll work out to be negative 10 plus 5z equals negative 15. We add the 10 over. It's going to look like 5z equals negative 5. We'll divide out the 5. And what we're going to have is z is equal to negative 1. Now we have both x and z. Now we can substitute into one of the very first equations. X equals negative 5 and z equals negative 1. I'm going to choose to use equation 1. I'm going to choose equation 1. For reference, equation 1 was x plus y plus z equals negative 4. If we plug in for x and z, we're going to get negative 5 plus y minus 1 equals negative 4. This would turn into, looks like y minus 6 equals negative 4. When we add the 6 over, we're going to get our solution for y equals 2. So now all together we have our solution for x, y, and z. It looks like negative 5, comma 2, comma negative 1.